Alright, so we're just going to pick up right where we left off. So this is example 3. So given the following functions, we want to find the equation of the tangent line at the point A, and we're going to be using Desmos to check our answers. So we're going to run through these, and at the end we're going to use Desmos to check our answers. So the first step in almost every problem you'll ever see in this class is you probably have to either find the derivative or work your way backwards and find the original function. So first off, we want to find f prime of x. So since we have a lonely x, so we're not multiplying by a constant or multiplying it by another x, we're just going to use the power rule. So that negative 4 is going to come down in front, and that will be x to the negative 5th. Now we want to know specifically what is the derivative at this point, a equals negative 1. So we're going to plug that 1, or I'm sorry, I said negative 1, it should be positive 1, into this derivative function. And we're going to get a slope of negative 4. So remember, the derivative is the slope of your tangent line. So what we need, remember, is y equals mx plus b. So we have a slope of negative 4. Our x value is 1. That's the same as your a value. We're trying to figure out what b is. And if I take 1 and I plug this into my x and my original function, it's going to be 1 to the negative 4th, which is going to give us 1. So that tells me that my b value has to equal 5. So the equation for my tangent line is y equals negative 4x plus 5. Great. By the way, that's your solution. Now on the next one, what I see here is that I see that I have a top part, and I also see that I have a bottom part. So what I'm going to do is I'm going to say, hey, my top part, that's going to be my f function, x squared plus 2x. And then this bottom part is going to be my g function. So 2x plus 4. Now, if I look back at how do I find the derivative when I'm dividing, that's going to be this guy right here. So I have to take the bottom part times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So what I need in order to figure this out is I need to figure out what f prime of x is, or the derivative of the top function, and the derivative of the bottom function. So the top function is going to have a derivative of 2x plus 2. The bottom is going to have a derivative of 2 plus 0. So remember, the derivative of x is just 1, because this can kind of have an invisible exponent of 1. So that'd be x to the 0, anything with 0 power is 1. So the derivative of my y function is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over that bottom part squared. So y prime will be 2x plus 4 times 2x plus 2. So that is g times the derivative of f minus x squared plus 2x times derivative of the bottom, which is just 2, all divided by the bottom squared, which is 2x plus 4 squared. Great. So now what we need to do is we need to plug in 4 for our x value. So that'd be y prime equals, let's see, so 2 times 4 is 8, plus 4 would give us 12, times 2 times 4 is 8, plus 2 would give us 10, minus, and then here we're going to have, let's see, 16 plus 8 would give us 24, times 2 would give us 48, all divided by, and let's see, we're going to have 2 times 4, which is 8, plus 4, which is 12, and then square that and you're going to get 144. So we are going to have 120 minus 48 divided by 144. And actually that's going to equal just 1/2. So we still need to find the equation of the tangent line. So let's see here. I have my m. I know my x equals 4, because that's just my a value. I need to figure out what y would equal. So let's see, if I plug 4 into here, I'm going to have 4 squared plus 2 times 4, which would give me 24, and then I have to divide that by 2 times 4, which would be 8, plus 4, which would be 12, so my y value is going to be 2. Alright, let's see if I can squeeze this in here. So we're going to have 2 equals 1/2 times 4 plus b, which means that my b has to equal 0. So our equation is going to be y equals 1/2 x. Great. All right, now for the very last one on here, let me give myself a little bit more room to work. There. Now on this last one, what we're doing is that we have one function, or one piece, that's being multiplied by another piece. So we're going to have to use the product rule here. So I'm going to let f of x equal x to the third minus 4x plus 5. And then I'm going to let g of x equal that square root of x plus 7x minus 3. So when I take the derivative of f, I'm going to get 3x squared minus 4. And then when I take the derivative of g prime, I'm going to get 1/2 x to the negative 1/2 plus 7. So the derivative of y prime, if you scroll up and you look at the product rule, is going to be f times g prime plus f prime times g. So in our case, that's going to be x to the third, minus 4x plus 5 times 1/2 x to the negative 1/2 plus 7 plus, and now we need to do f prime, so 3x squared minus 4 times g left alone, which is the square root of x plus 7x minus 3. Great, so we actually want to find y prime at 1, so we're going to plug in 1 for all of these x values in the derivative. So we're going to have 1 minus 4 plus 5 times 1/2 plus 7 plus 3 minus 4 times 1 plus 7 minus 3. Remember, 1 raised to any power is going to give you 1, and then anything times 1 is just going to give you that number. So that is going to end up equaling 10. So if we plugged 1 into the original function, remember, this is going to be our m value, our x value is 1, and our y value, so if I plug 1 into this, I'm going to have 1 minus 4 plus 5 times 1 plus 7 minus 3, which would also give me a y value of 10. So I will have so I will have 10 equals 10 times 1 plus b, so I get b equals 0, so that would be y equals 10x. Wonderful, and as I promised, we're going to go ahead and hop on to Desmos to check our answers. Go to Desmos. So what we are going to do is we're going to type in the original function. So I'm going to call it f of x equals x to the third minus 4x plus 5 times, now if you just try SQRT, it'll automatically make a square root for you, plus 7x minus 3. And now what we're going to do is that we are going to type in the equation of that tangent line. So that's going to be y equals 10x. All right, so if we zoom out, what we should see is that we should see that that line hugs our curve right when x equals 1, so right about here. And if we look, it certainly does. So we did a great job. All right, let's check our other two and make sure that we did a good job on those guys. So let's go ahead and type this one in and see how we did. So that original function, which again, I always like to call f of x, but you can do whatever. F of x equals, remember we have to put both the top and the bottom in parentheses, so plus 2x, divided by 2x plus 4, 2x plus 4, okay? And the equation of our tangent line was y equals 1/2 x. All right, and let's make sure that that lines up. So we wanted it to line up when a equals 4. So let's zoom in a little bit. All right, it looks like they line up actually pretty perfectly. You can see that one's right on top of the other one. So that was great. We did such a good job. All right, and let's check the very last one. Whoops. All right, so the very last one that we wanted to check was x to the negative 4th. All right, and the equation we had for our tangent line was y equals, let's take a look here, negative 4x plus 5. All right, and we were looking at when a equals 1. So if we look at when x equals 1, we can see right here that we do have a nice tangent line that hugs our curve. So we did super awesome. All right, so we're on to the very last example here. And what we want to do in the last example is that we want to use the chain rule to find the derivative of this function. So first, when we look at this, notice that we have this whole thing, 4x cubed plus 2x minus 1 to the 5th power. Okay, so that's to the 5th power. So what this means is that our outside function is that we have something raised to the 5th. And our inside function is that thing that we're raising to the 5th. So that's 4x cubed plus 2x minus 1. Now what the chain rule says is that it says if you're finding the derivative of one function that's inside of another function, what you're going to do is find the derivative of that outside function times the derivative of the inside function. So if we look at the outside function, well, the derivative of something to the 5th power is 5 times that something to the 4th power. And then the derivative of the inside part, that is the 4x cubed plus 2x minus 1, is going to give us 12x squared plus 2. So if we take these and we put them together, that's going to be the derivative of the outside times the derivative of the inside. However, notice that this has a u for the variable, and this one has an x. So what we can do is, remember, we were like, hey, let u equal this guy. So we can re-substitute in our original function. This is the way that your book describes it. Here's how I like to do it. It just seems a little bit more fun and a little less formal to me. Is I just remember this. If I'm taking the derivative, I'm going to take the derivative of the outside. So something to the 5th power would be 5 times, now leave the inside alone, times, now, since I left the inside alone, now I'm going to multiply by the derivative of the inside. You are always welcome to just leave this as it is. You don't have to simplify it. I'm totally okay with that. I'd actually rather you guys leave it like that because it makes it a little bit easier for me to grade. All right, cool. So I want to show you guys one more thing. I might regret this, but we will see. The last thing I want to show you guys is if you go into Google and you type in derivative calculator, and you go to the very first link, what it does is it gives you the ability to do the derivative, but the best thing is that when you put a derivative in, it'll tell you the steps. So if we did x to the third plus 7x all to the fifth, what this will do is it will give you the derivative, but you can also hit show steps. And it will show you, hey, to get from here to here, we are using the power rule. Another word for the power rule is the chain rule. Okay, and you can click on it and it'll do all that good stuff for you. Alright, so that concludes the last video showing you some examples from 2.4 and, or I'm sorry, not 2.4, 9.4 to 9.6.